Hi student, myself Santosh and you are watching my channel at the rate Gain Knowledge World. Please subscribe my channel, like and share and press the bell icon for the latest update. Lastly, we are studying the exercise 7.1 and due to circumstances the video got disclosed and I had started the videos from the same place where we have ended the video last. By this you can the third question is AD and BC. AD and BC are equal perpendicular to the line segment AB. Okay, so that CD bisect AB. CD bisect AB. How this will be proof? Again, the same. This side is equal. This angle is equal, and if the angle is one angle, we again or our side again we will find equal, then we will get the solution. So you can see this angle, both these angles are equal by what? Vertically opposite angle. By vertically opposite angle you can say that this angle BOC and AOD are equal. Now move to the next question 4. In again question 4, is AD and BC are parallel, means line L and M are parallel, because of which this triangle, both the triangles are formed. Okay, so we have to prove the ABC and ADC triangle congruency. You can see this is a common side, so it is equal, and you can see this angle and this angle are equal. This angle and this angle should be equal. Why? Because of the two parallel lines are going, and because of which this two is this and this will be corresponding angles, by which the triangle ABC and ADC will be congruent. Now coming to the question number 5. In question number 5 you can see that this is the easiest question I have seen ever from the after the first question. Here all the things are given here. Okay, you can see this angle and this angle are equal. Okay, and due to L is the angle bisector of A and B, then this angle and this angle should be equal. Okay, two angles we have to get the equal. Now this side AB is also equal, because in both the triangles this angle line is common. So triangle ABP and QBA both are congruent to each other, and by which BP and BQ both are equal. Okay, after the congruency you can prove all the sides if are like same can be equal. Now you will solve the question 6, 7, 8, all are equal like questions, and you can find the answer easily. Now coming to the 7.4, the another concept, which is some property of a triangle. What it means is, इसका मतलब होता है कुछ प्रॉपर्टी ट्रायंगल्स के. ठीक है, what are these properties are? Let's see in this triangle, which is theorem 7.2. Here the theorem is explaining us about in an isosceles triangle. Let's suppose ABC is an isosceles triangle, in which in an isosceles triangle we know that two sides should be equal. Okay, so if AB and AC are equal, then the angle opposite to them, the angle opposite to AB is angle C, and angle line AC or side AC opposite angle B. Then it means is the whole summary is, if a triangle is isosceles, the angle opposite of equal sides should be equal. This is the summary of whole theorem. Okay, now coming to the 7.2 theorem, the side opposite to equal angles of a triangle are equal. This is a controversy of theorem 7.2. What it means is, what we have proved in the theorem 7.2, it is opposite of. It means is, if two angles are equal, then the side should be equal. Okay, opposite side, if angle 50 and 50 is this, then this side and this side should be equal. This is a property. Always you remember the properties of the triangle, circle, or whatever the figure should be, because this will help in the other or the upper classes in your life. Here is an example, which is example number 4. We have to prove AB and AC should be equivalent. Okay, and there is a AD, which is angle bisector of triangle ABC. By the angle bisector, we know that angle bisector bisects the angle by which, because of which the name is angle bisector. So angle bisector bisect the angle A in equal parts, which means we got an angle equals the second angle. The angle bisector always perpendicular to the base of a triangle, so this will be also equal. Two angles have equal, there is only one side should be equal and the congruency will be equal. So you have can you see the one side? That's the side is AD, which is common to both the triangles. So as A, we get a congruency of triangle ABD and ADC, by which we can prove the AB and AC should be equal in a and AB, and if AB and AC should is equal, then triangle ABC is isosceles, because it is a property of isosceles triangle. Then two sides of a triangle is equal, and for the equilateral triangle, all the three sides are equal. You can see in the triangle in the example 5, in this triangle we will take a triangle BCE and BFC. Okay, because of midpoint of AB is E and AC is F, this side and this side should be equal. Okay, now this is a common side, and we got sorry, the misconception I have told. Not we have not to take this, we have to take this triangle, because this is common, this triangle and this triangle. Okay, means AEC and ACE. In this triangle, this angle is common. Okay, this and AB and AC are equal because given, and the third thing is AF and AE should be equal, because the larger side is equal, then half of the side is equal. So by SAS we have proved the example number. In example number 6, we have to prove, okay, we have to prove AD and AE are equal. Okay, so this is a isosceles triangle, so this side we will take ABD and ACE. In this triangle, this and this side should be equal, because isosceles triangle, this angles are equal. Because of isosceles triangle, the opposite angles are equal if opposite sides are equal. Okay, we got a angle, we got a side. Now we have to take this and this. Okay, if BE is in the given question, BE and DC are equal. Okay, so uh, DE is equals to BE minus BD. Okay, and DE is equals to CD minus CE. So both are equal, by which we get BD is equals to EC. So hence we got ABD and AEC be congruent by SAS congruency rule, and because of which this side and this side should be equal. Here is the first question given. You will solve it by your own. It is easy. The second question we have seen. This is the figure given. We have to prove this is isosceles triangle, and this is the ED is a perpendicular bisector, not the angular bisector. Perpendicular bisector means this will fall on 90-degree, but it will divide the base in equal parts, because of which perpendicular bisector is named. So we get a side equal, angle equal, and this side will be also equal because of the common side of triangle ADB and ADC, by which we can prove that ABC is a AB and AC is equal, and ABC is a isosceles triangle. Now coming to question number 3, what we have to do in it is take triangle ABE and AFC. Okay, AFC, there is a common angle A. Second, there is a equal angle, okay, 90 in both side. And the third is there is a equal side, AB and AC equal, because ABC is a isosceles triangle. So by angle side angle ASA, this will be congruent. Now coming to question number 4. Here in question number 4, the thing BE and CF both are equal, and we have to prove this triangle and the whole triangle is isosceles. How we will prove is, there is a side we have given which is equal. So the first point we have achieved. The second point is the common angle we got, which is the second I can say important thing we have here given here. And the third thing is what, again this angle and this angle both are equal, because of which we can prove the triangle be congruent because of side angle side angle side angle, and by which we can prove that AB is equals to AC and the ABC is a isosceles triangle. Question number, now coming to question number 5. In question number 5 we have to prove this triangle and this triangle be equal. It is easiest. I can say two sides are given, okay, there's a common side is given, okay, and we have to prove is, in question number 5 it is quite hard because to understand, because there is not a sign given here for proving. I am not aware of, is it asking about to show the triangle is equal or congruent, or the side is equal, angle is equal. If angle is equal, there is a side here, okay, and due to both the triangles are isosceles, then let it be put in the star. I will tell you after, then in the next video, what is the answer of it, okay. Now coming to question number 6. ABC is isosceles triangle in which AB and AC are equal. Side BA is produced to D such that AD and AB is equals to equal. Okay, all the three are equal, so that BCD is a right angle. Okay, in this triangle we can say this is isosceles triangle because of the two side equal, so this angle should be equal. Okay, if this angle in this ADC, if both the sides are equal, then the triangle should be equal. And if by proving that in triangle ABC and ADB, this angle and this angle should be equal because the sides are equal, at this angle and this angle should be equal because of the sides, and there is a only angle which is be equal in this case is in BCA and DCA, which is 45 degree, and if you add the 45 degree two times, then you will get the 90 degree. So DCB will be 90 degree. We have now the question number 7 and 8 all are easy. We have to prove it by own. Okay. Now coming to the second, it is not the second, it is the fifth concept. Some more criteria for the congruence of triangle. Okay. In theorem 7.4, here we have to prove SSS rule. By we have to prove the triangle congruency by SSS rule. SSS rule means all the sides are equal. Okay, like here you can the example of which this side and this side is equal, this side and this side is equal, and this side and this side is equal. So by this we have to prove this. All the theorems in this given chapter you have to thoroughly revise and remember, because this is the most important theorems you have to be learned in this class and the again 10 in the class 10th. Now coming to the theorem 7.5, RHS congruency rule. If in two right triangles the hypotenuse and one side of one triangle are equal to hypotenuse and one side of the other triangle, then the two triangles are congruent. Why? Here is the example. Let's suppose this angle, this side and this side is equal, this side and this side is equal. Okay, and there is an angle, this angle is equal. So this is a right angle hypotenuse side, which is RHS congruency rule. Mostly you have not used this rule, but all the other rules which I had told you before is most important rule, because it is satisfied only for the right angle triangle, and the others are to any of the triangles. In the example 7, we have to take the we have to take or we have to prove first. I have telling about you that AC and CB should be equal. Okay, we have to prove it. So we should take PQ, PAQ and PBQ as a triangle, okay, in which we have given this in the according to the question, this and this equal according to the question, and this PQ is a common because of the common side, okay. So by SSS congruency rule, we have proven that PAQ and PBQ is a congruent, by which you can also prove that AC and CB will be equal because of congruency. Now in this example, we can see that PB and PC are equal as per given. PCB, PCA and PBA are equal because of 90 degree, and both are 90 degree, and a common PB, AP. So we can prove that AP is the angle bisector of what? Angle A and angle P. We have to prove in exercise 7.1 in question number 1, ABD, triangle ABD and triangle ACD is equal. Since ABC and DBC is isosceles, so this and this will be equal, okay. You know how. And the AD, this side will be common, so by SSS it will be proved. Now second question is APB, ABP and ACP. What we have to do is this and this will be equal. Why? because of because of isosceles. This angle and this angle will be equal because of isosceles. So this and the triangle and line, line AP will be equal due to common line in triangle APB and APC. Now we have to prove AP bisector of angle A as well as D. You can prove that because both the triangles are congruent, and if both the triangles are congruent, you can prove that this angle and this angle will be equal, this angle and this angle should be equal, and AP is the perpendicular bisector of BC. For this, we have to prove this angle and this angle are equals to 90 degree. Nothing is hard here or tough here. Now the question second, third, fourth and fifth, all the questions are easy. You can do it by your own on home. Now coming to the concept, which is 7.3, inequalities in the triangle. It is a theorem in 7.6. If two sides of a triangle are unequal, okay, let's suppose in here two sides are unequal, okay, the angle opposite to longer side is large. Except exactly the same thing is if this side has a longer length as comparison to BC, then this angle will be larger than BC, okay. You can measure it by using the protractor if you have. Now coming to theorem 7.7, if in any triangle the side opposite to larger angle is longer, okay, the theorem it is about the same thing of 7.6 theorem is telling us about. The theorem 7.8, the sum of any two sides of a triangle is greater than the third side. Yes, we know that. It is if you do not know that Pythagoras theorem, so I will telling you about that. It is the most important theorem of the triangle. So in the right angle triangle, if there is always a proof that sum of a largest sum of the two smallest side, which is DC and BC is always greater than DA, okay, which means in the Pythagoras theorem it is given through Pythagoras theorem, that for which the Pythagoreans derive the formula, which is dB square is equals to BC square plus DC square. As per you know about the exterior angle, I had told you in the last or the second last chapter that there is exterior angle. Let's suppose in triangle BABD, ADC is the exterior angle of ABD. So in this case we have to prove, so we are going to prove by this process that let's suppose ADC is a triangle, okay. Here this angle are equal, so this angle and this angle will be equal, okay. But we do not know about this angle. So in triangle ABD, ADC is the exterior angle of ABD, and as we know, exterior angle is always greater than the second this angle, means ABD always greater than this angle which is in the front of it. So this angle will be always small. So if this is a small, then this will be larger than this angle, and if it is larger, then this side will be larger. Okay, so AB is larger than AD. What we have to prove is, we have proven the theorem, the theory. The exercise 7.4, this exercise is wholly depends on the whatever I had told you in the last example. Okay, in this exercise all the things are have to prove through this theorem. Okay, here you have to prove PBC is less than ACQ. Why? Because this angle is a right angle, because this angle is not isosceles, not right angle triangle. So firstly we have to take that. In the second question, I am telling about the second question. Here PBC is given is less than QCB, and we have to prove that AC is greater than AB. Let's suppose this is the angle, okay, theta. So this is 180 minus theta. What you have told you before, that this is a line, and line makes 1 degree of 180 degree. So 180 degree minus theta. Let's suppose this is angle theta, not theta, what, phi. Okay, phi is also measure of angle, so you can take as a phi. So this will be 180 minus phi. Okay, if this angle is, since this angle is lesser than this angle, so now this angle will be larger than this angle because of 180. Let's suppose this angle is 90, not 90, 80, and this angle is 100. Okay, so this angle will be what, 100, and this angle will become 80. So if this angle is greater than this angle is greater than this angle, then this side AC will be greater than AB. Okay, the third question is also easy, you can do it by own. The fourth and the fifth, all the questions are easy. If you solve the question as per I told you in the second question and the example earlier, you will solve all the question which is given in the example 7.4. This is exercise 7.5, which is optional and not going to come in your exams, but it is for the purpose of maintaining the toughness of the subject or the toughness of the chapter. So if you want to take two, you can comment in the comment box, and I will solve this for you. Okay, so this is the summary, the main thing of the chapter. Always remember that summary should always be remembered, because this is the crux. What this means is पूरा chapter का जो पढ़ा हुआ, which is crux of the chapter. So you have to study the summary in the last, and it is not something, it is a 10-minute revision practice. As per I, this is 10-minute revision practice for you. Okay, by reading this you can revise the things you have learned here. Now the next day, whenever I get the time, we will cover the quadrilateral chapter. For today it is okay. I hope you will enjoy the session, understand all the things I have told you. So thank you for your support. Please subscribe my channel, or your channel, or our channel at the rate Gain Knowledge World. Subscribe it, like if you like the video or enjoyed the session, share it to your friends or family members who are the children of class 9th, and press the bell icon for the latest updates of my videos, by which you can get the revision of this chapter. Or if any problem, comment on the comment box, so I will give the answer of that. So thank you.